Welcome back, everybody. Okay, so you had a worksheet to practice addition method and some word problems. Here's the first one. In order to do the addition method, everything should be lined up. The x's are lined up, the y's are lined up, the equal signs, the answer numbers. Okay, now, when we add straight down in the columns, one of the variables has to cancel out. If you look at each column, nothing does. So we need to pick a variable and get the coefficients to be the same, but opposite signs. So let's go at x for this one. The 4 and the 3. We need to somehow change them so that the numbers are the same, but with opposite signs. Can you think of a number that we can change the 4 and the 3 into by multiplication? 12. Okay. There are other options. 12 is a good one though. If we multiply this top equation by 3, it'll change to 12x minus 9y equals 33. You multiply it to all the terms. We got a positive 12 for the top equation, so we need this number to become a negative 12. We should multiply everything by negative 4. So that'll give us the negative 12x. Negative 4 and negative 5 multiplies to give you 20y equals 44. Okay, now if we look at the equations again, if I add straight down in the columns, the x's, 12 minus 12, they cancel. We just need to add the remaining columns. This gives us 11y. This is 77. Now that we have only one variable, we can solve for y. Divide both sides by 11. Okay, our y value is 7. All we gotta do now is solve for x. We take the 7, pick either equation, and replace y with it, and then solve for x. I'll take the top one. 4x minus 3, and in place of y, we're going to put the 7. And now we solve. We need to get the 4x by itself. To get rid of the negative 21, we're going to add. So that's gone. 4x equals 32. We need to undo the multiplication. Okay. Let's look at the next one. Okay, we're going to do the addition method again. You look, all the columns are lined up, all the x's, all the y's, the equal signs, the answer number. Is there a variable that'll cancel if we add straight down in the column? Right there, the y. Same number, different signs. If I add straight down, they cancel. If we add the other columns, this is 8x equals 16. Now we just solve for x. Okay. We take the x, replace it in one of the original equations, and we solve for y. Okay, last time I took the top one, I'll take the bottom one this time. It doesn't matter which one. It's supposed to work whichever one you choose. So 5, and in place of x, I'm going to put the 2. Minus 7y equals negative 32. So this is 10. Okay, we need to get the negative 7y by itself. We need to get rid of the 10. To get rid of a positive 10, we need to subtract. So that's gone. That's a negative 7y. Don't forget the negative. This is negative 42. And then we divide both sides by negative 7. Y equals 6. For those of you that tried and put the 2 into the top equation, you would have had the same answer. Let's look at the word problems. Here's the first one. Rockfish average 2.5 pounds. Bluefish average 8 pounds. The total weight of the catch is 137 pounds, and she caught 24 fish. We need to figure out how many of each fish that did she catch. Okay, so we need to set up some variables first. The 2 things that need variables are the rockfish. Okay, we'll use R. Number of rockfish. And therefore, the other variable will be bluefish. The number of bluefish. We'll use B. Okay, now, each of these sentences will have their own equation. Total weight of the catch was 137 pounds. She caught 24 fish. Okay, I'll start with that one. All the fish put together came out to 24, so we know it's equal to 24. All the rockfish and all the bluefish. All the rockfish and all the bluefish come out to 24 fish. Okay, the second equation will deal with the weight. Keep in mind, these are the weights for the fish. So a rockfish averages 2.5 pounds. A bluefish averages 8 pounds. And the total comes out to 137 pounds. So somehow we have to use the 2.5 and 8 in this equation. The rockfish, 2.5 for each. The bluefish is 8 pounds each. There. That's your system. The method you solve is up to you, although the way it's set up right now, one method is better than the other two. Personally, I would never use the graphing method, especially with something like 137. So it's either substitution or addition method. If you look, the R's are lined up, the B's are lined up, the equal signs, the answer number, they're all lined up. Addition method would be better here. Okay, so pick a variable. We're going to eliminate. We need the coefficient to be the same with opposite sign. I'll get rid of the B. This is positive 8. This is a positive 1. So if I can get this to be a negative 8, we can cancel the B. I'm going to multiply the entire top equation by negative 8. So negative 8R minus 8B equals negative 192. Did I do it right? Yeah. Okay, 2.5R plus 8B equals 137. Okay, so if you look, the B, same coefficient, different signs, they will cancel if I add straight down. If I add straight down here, negative, what is that? 5.5 R. If I add straight down here, it's negative 55. Oh, okay, that comes out nice. If I divide both sides by negative 5.5, that cancels. R equals 10. Now we know the number of rockfish, we can figure out the bluefish. We're going to replace R. I'm going to use the first equation. 10 plus B is equal to 24. All I do is replace the R with 10. Now we solve for B. So 10 rockfish, 14 bluefish. Let's try the next one. two different senior classes from different high schools are going to go to the state fair. High school A, they're going to fill up 8 vans and 8 buses with 240 students. High school B, they have a small senior class. They're going to fill up 4 vans and 1 bus with 54 students. Each van is going to hold the same number of students regardless of the high school. Each bus will hold the same number of students. We need to figure out how many students in a van and how many students in a bus. Okay, we need variables first. The two things that need variables. No, it's not going to be high school A or high school B. There's something else that needs variables. The vans and the buses. Let's see. V stands for number of students in van. B stands for number of students in the bus. Okay, look at that first sentence. 8 vans and 8 buses hold 240 students. That's kind of straightforward. You have 8 vans and 8 buses comes out to 240 students. The second sentence, 4 vans and 1 bus is 54 students. 4 vans, 1 bus holds 54 students. There's your setup. Now, you pick a method and then you solve for the number of students in a van and students in a bus. One of the methods is better than the other two. Since everything is lined up, addition method would be better here. Okay, so we're going to use the addition method. We need to get rid of one of the variables, make it so that the coefficient is same number, different sign. Let's get rid of the V. We need these numbers to become the same. I can change the 4 to an 8. This is positive 8, so I need this to be negative. I'm going to multiply this one by negative 2. The top one stays the same. If I multiply everything by negative 2, that will give me negative 8V minus 2B equals negative 108. If I add straight down in the columns, the V's will cancel. This will give me 6B equals 132. Now we just solve for B. 22. So the bus holds 22 students. I'm going to take this number, put it one of the original equations, and we're going to solve for V. I'll take the bottom one. 4V plus, in place of B, we put 22. Now we solve for V. We need to get 4V by itself. I'm going to get rid of the 22. 4V equals 32. Need to undo the multiplication. A van holds 8 students. One last problem. We have 150 coins in the jar, nickels and dimes only. It holds 12 more nickels than dimes, or that's how much there is. Yeah, 12 more nickels. How many nickels and how many dimes are in the jar? We need two variables again. The nickels and dimes. N stands for the number of nickels, D will stand for the number of dimes. Okay, there are 150 coins in the jar, all nickels and dimes. We can write that as an equation. You know, it comes out to 150 coins. All the nickels and all the dimes put together comes out to 150. All the nickels and all the dimes. Second sentence. There are 12 more nickels than dimes. Keep in mind the equation that you write, it should make sense that there are more nickels. Well, okay, let's see. There are more nickels, so that's the bigger number. So the smaller number, if I add 12 more to it, yeah, so the small number plus 12 will give us the bigger number. That's one way to look at it. Another way you could have gone is, let's see, you have more nickels. If I take away 12, I get the smaller number, the dimes. Technically, if I take the big number minus the small number, there's a difference of 12. Yeah, so any of these would have worked. Okay, I'll go with this one. So I'll use these two equations. If I use these two equations here, and you pick one of the methods to solve, one method is better than the other three. You have a variable by itself. Substitution would be better here. I'm going to replace n with d plus 12. So right here, in place of n, so wait, let me write it here. In place of this n, I'm going to put d plus 12. The rest of it will stay the same. Yeah, so in place of n, I just erase it. I put d plus 12, substitution method. Now we solve for d. We can combine some terms, get d by itself. There are 2d plus 12 equals 150. We need to get the 2d by itself. I'm going to get rid of the plus 12. This will give us 138. So d equals 69. So 69 dimes. We take this, replace it for d in one of the original equations, and we solve for the number of nickels. I'm going to put it in that equation. N equals, in place of d, I'm going to put the 69. What is this? 81 nickels. Does it add up to 150 coins? Okay. Do you have 12 more nickels than dimes? There you go. These are your answers. Okay. Hope that helped. I'll see you in the next one.